we've already done using tables to graph. We've already done that. So we're just going to do that again. Okay, we're going to use our tables to graph these two equations together, side by side. So we've done that for a couple days now. So everybody finally got in. I see yes. All right, so use the tables and the graph to check the solution for the problem. Barbara has a bunny that weighs 5 pounds and gains 3 pounds per year. So here's a bunny. Okay. Her cat weighs 19 pounds and gains 1 pound per year. When will the bunny and the cat be the same weight? Okay, so our years, I'm on text for a reason. First, we have to put our name on this. Okay, second thing, I gotta change how big this is. Oh my goodness, this is 14's too small. Okay, so maybe let me fix this. Okay, so we're gonna have to look at this and figure out when are they gonna cross. Okay, first thing, the years are going to be our x values. Okay, the years are the x values for both of them because we're using the same years. The pounds are the y values. Okay, the pounds are the y values. So I'm going to make the bunny blue, and I'm going to make the cat red so that I can tell the difference. Okay, is everybody okay with that? Put your marks on, put your X's there, make the bunny blue and the cat red. So we're going to do the work for the bunny in blue, and we're going to do the work for the cat in red so that, we can tell them apart. All right. So year 1. This is going to be the years after this moment. So this moment is start. So it's year 0. Oops, should be blue. Sorry about that. This is year 0. The bunny weighs how much? According to the instructions, the bunny's start weight, which would be year 0, would be what? I have a couple people with private messages. Please handle that. Okay. So 5 pounds. So we put a 5. But I have to remember to change it over to the. Because we're doing everything in blue for the bunny, right? Okay. So now we're on year 1. A year has passed. How much does the bunny weigh now? What does it say the bunny grows? What's its growth? Okay, so we're in year 1, right? We're in year 1. And the bunny now weighs what? Bunny now weighs 8 because we said it was a growth of 3. Okay, year 2. What now for the bunny? What now for the bunny? Hello. Keep going. Someone tell me the next one. Okay. 3, 4. Now, has the bunny caught up with the cat yet? No. You gotta keep going. Week 5. Year 5, sorry. Now, technically, it looks like the bunny might have caught up, right? Because the bunny's number is bigger than the cat's number. But remember, the cat's been growing too, so we can't assume anything. So we need to finish up our table. Year 6. What's it going to say? Year 7. 26. Lily, how likely is it to have a bunny that's 26 pounds? Can a bunny get that big? Because I know you have a bunny, right? Lily, can a bunny get to 26 pounds? Yeah. Oh, Brianna, you have a bunny. Can a bunny get to 26 pounds? I think Lily has one too, right? Yeah. So she, no, I saw. Maybe it was last term. I never remember last term. Maybe she was with the bunny. Okay, so we finished the bunny. I want you to go finish the cat. Go do the cat really quick. Top line is going to be 0 through 7. Make sure you change your color to red because you're now doing the cat. How much is the cat changing though each year? Only by 1. All right, so go fill in the cat's table. I'm not going to talk, just fill in the cat's table. So the X's are never going to be different between the two situations. Okay. You guys almost done with the cat? I have a couple people with private messages. Handle it, please. Are we almost done with our cat? What did the cat start at? Okay. So you guys should almost be done because you're only going up by one each time. Keep going. I'm just gonna be writing it. You're writing it for yourself on yours. You don't need to say it in the chat right now. Thank you for telling us. But you guys go fill yours in. I'm gonna go fill mine in. We don't need to chat this one. It's only one each time. Okay, so you guys should have yours filled in, right? So when you're looking at the table, how do we know it's the solution? We learned this last week. What makes it the solution when we're looking at the table? What makes it the solution when we're looking at the table? What are we looking for in the table so we know it's the solution? What are we looking for in the table so we know it's the solution? What are we looking for in the table so we know that's the solution to the system? When will the bunny and the cat weigh the same? Okay, so it has to be the same year and the same weight at the same time. So even though Kitty was 23 pounds and Bunny was 23 pounds, were they 23 pounds at the same time? No. So we're going to go ahead and circle in the table the year when they were both totally identical. Okay. And this is the year for the bunny. This is the year for the cat when they were the same. Okay. So far, so good. And we're going to get the coordinates for this table. So what are the coordinates for the bunny? What are the coordinates for the bunny? Okay. So we know the first one was 0, 5, right? What's our next one? What's our next coordinate for the bunny? Because we need the coordinates for the ground. What's the next coordinate for the bunny? First one was 0, 5. What's the next coordinate? 1, 8. Keep going on your list. What's the next one? Keep going. Tony, read your private message. What's our next one? Someone else. What's our next one? Remember, to be coordinates, what does it have to have to make it a coordinate, not just two numbers separated by a comma? We need to make sure they're in what? In a parenthesis. So we still haven't done the fourth one correctly. We need to fix that one, or we can go on to the other ones. How would we correctly say year 4? Yeah, 4, 7 in parentheses. Okay. And then we had a year 5 and a year 6. So we just had to do our year 7. 5 was 20. 6 was 23. And 7 is 26. Someone Google for me if a bunny can get to be 26 pounds, because that seems like a huge amount for the poor. I mean, when you think of bunnies, you think little, right? I made it smaller so it fit. Now, are the x coordinates going to be different for the cat? Are our x numbers going to be different for the cat? No. So I'm going to copy this list that I just made for the bunny. Okay. Copy the list, change to red, post it down with the cat. And I have to change its size too, but I'm just going to go in and change the y numbers because I know the x numbers are the same, right? Don't work hard, work smart. Since you already have it already formatted, all you have to do is go change the x numbers to the cat's numbers. 19, 20, 21, okay? Use your cut and paste ability that Candy gives you to make it quicker. They can weigh as much as 20 pounds or more. I guess so. It just seems so big. It seems huge for the cat too. 26 pounds is a crazy size, but some of the specialty cats are like that. The Bengals can get big like that, and the Maine Coons and things like that. Okay, so we have our lists, right? And we need to go graph. So I'm going to copy my bunny list again down below so I can graph with it. Except that one should be blue, right? So I'm changing them to blue by just going here and changing it to blue. Okay. And I'm going to copy the cat list down. First, I have to remove the bunny list. So I have my 2 lists down here so I can use them. Okay. Yeah, working smart enough. All right, so now we're going to make a graph. What is the x direction going to be? Because here's my x direction, right? What are we measuring on the x direction? According to our table, what were we measuring on the x direction? Years. So with a text box, we're going to say number of years. Okay. And then we have our y direction, which is up here. And according to our table, what does the y stand for? What does the y stand for? According to our table. Pounds. Now, when you go to write it on the table, use the real word. Okay. We only abbreviated it in the table because we wanted to say just. All right. So how many years were we looking at? Really? 7 entries? Okay, how many entries do we have? year 0 up to year 7. So there's 8 entries altogether looking at, okay? So, but we have to be able to go out to x of 7. How many lines do we have to work with? 1, 2, 3. How many lines do we have to work with? 15. And we only need to go 7 years worth, right? So we could do every other line is a year. So let's do that because it makes it easier to see, right? So 1, skip, 2, skip. Because we have space, we can go every other line. We don't have to squish them together. Right? And these do not have to be super duper big or really outstanding, or it's just a little bit to tell what's going on, that we went out 7 spaces. Each line stands for 7 when we put that on there. All right? So that handles the years. Now we have to handle the weight. How many lines do we have to work with? $15 again. Can I skip? Because how high do I need to go for weight, for our pounds? How high are our pounds going? 26 pounds. So could I skip with 15 lines? Can I skip like I did the 7? No, so we have to use every line. Okay, so I'm gonna go get my lines. I'm not so worried about them being perfectly straight. For those of you that are really weird about it, go ahead, but don't spend so much time worrying about them being straight. It's just highlighting the fact that it's there, okay? I know there's ways to make it perfect and pretty and stuff, but it's not critical. Now, I have 15 lines. I need to go 26 pounds. Can each line stand for 1? No. How much must each line stand for? What are we going to say at the top here? If we have to have 26 pounds fit, each line has to be worth how many? We have 15 lines and 26 pounds has to fit. So what does our top number have to be? What is each line worth? Come on, up and down. How much is each line going to be worth so that we can fit 15 lines but go up past 26 pounds? 2. So what's the top going to say if each line's worth 2 and there's 15 lines? $30. Exactly. Let the person know that each line's worth 2. Okay, now we're going to go graphing. The first one is blue. So we're going to get our dots and we're going to make sure they're 4 and we're going to make sure they're blue because that's the bunny. At year 0, it's 5 pounds. But each line up is worth 2, right? So that's 2, 4, And halfway will make us 5. Put our dot. Then we're on year 1, and it's 8. So 2, 4, 6, 8. So if you notice, every other year for the bunny is an even number, and every other year is an odd number. So on the odds, they have to go between, because we're going by 2s up and down. And the evens, they get to be right on the corners. So 2 is 11. 2, 4, 6, 8, 10, and halfway between 10 and 11 is 10 and 12 is 11. Now, that's over 1 year. That's up 3 times. Showed you guys this on Friday. Over 1 year, up 3 times. So you don't have to keep counting from the bottom. And we're connecting to make our button. That should be kind of, yes, the ones that are in the odd years might be slightly off the line. Do not stress about it. That's because we have to kind of estimate where that odd number is. Okay, we're going to go do the kitty. 2, 4, 6, 8, 10, 12, 14, 16, 18, halfway between them. The kitty was going over 1, up 1, over 1, up 1. Remember, up 1 is halfway in between. Because we're going by 2s. And we land at the same spot, which we knew would happen because we already found on our table that they crossed at the 7th year and 26 times. But at that point, should the growth stay the same, which we know it won't because you don't continually grow forever. Should the growth stay the same, the cat would be less weight than the bunny. That's when they trade spots. Okay, so the only thing we have left to do is go copy our coordinates onto the graph. Okay. What I am going to do is put the bunnies down below, and I'm going to put the cats up above. So that way I can, not have them bump into each other too much. And our picture confirmed the table. So we did this for 3 days now. Plus we did the graphing stuff back in chapter 4 and I believe some in chapter 3. We've done graphing before. This is just graphing more than one thing on the same picture. It's not new stuff. And I'm going to change this 726 to green because it is where they crossed each other. Okay, it is where they crossed each other. It's not that it's bunny or cat, because bunny's blue and cat's red, right? It is, that's where they crossed each other. So I changed it to a green. You do not need to do that. It's my personal choice. I kind of like having it clear. Now, since cat's not going up quite as much, notice I put his first coordinate out off the graph. So I had space to put the other ones. Because bunny's going up by 3, there's a little more space to fit the coordinates. And there's some that you're gonna have to put a little bit higher and some that you'll put a little lower, and it's fine. Just they're in the general area so that people can know what the point means. Okay. That's another trick you can do. One down, one up. Okay. Let's see if we can go up. It's just a visual. You're visually explaining what the dot is. I do expect the coordinates on the graphs. I know some other teachers don't. That is their choice. My choice is you're going to have coordinates on the graph. You need to know how to do that. Later on, it matters. So we might as well start with good habits now. And one of them is to be precise with it. Okay. Any questions about how that worked? Any questions about how that worked? That should seem familiar because we've done graphing a bit. Okay. Okay. So now let's go look at another way. And we talked about it. We started talking about it on Friday. Now we're continuing. And that's solving an algebraic way. Graphs can be very messy. There are times when making the graph of a situation is not a good way to go. Okay. Especially if you have partial things. Like, so if you have fractions and decimals and stuff in your situation, graphing is not the way to go. So what they did is they took the situation that they were talking about back in 41, and they gave us equations for them now. The only problem is this the right format for these equations? Are these equations in the right format? Is that what our format's supposed to look like? No, what's our format supposed to look like? What's our format supposed to look like? Yeah, so they did this middle part backwards. So we're gonna go ahead and fix it. So this would have been y equals 3x plus 5, right? For the bunny. Yes. And then our cat would have been y equals 1x, but remember we don't write the 1 plus, we just say x, 1 is 1. Because 1 times doesn't make a difference. Now, it says that 41, which we just did, asked you to determine when the weight for the cat and the bunny were the same, but they had you go ahead and do it graphically and with the table of values. Now we're going to look at it just from the equation point of view. No big table of values, no graphing, none of that. We're just going to look at the equation point of view. Here are my two equations, right? If I want to show that those equations are in balance, what would I do to them to make it show that they're in balance with each other? How could we show that they're in balance with each other? We did it on Fridays. Think about what we did with our two equations. How did we show that they were in balance with each other? We wrote them equal to each other, right? That is all that question's asking. What equation would show their imbalance? In other words, how would we be able to go solving? Well, we'd set them equal to each other. Because the point of intersection is when they're equal. Okay? Now we're going to take this equation and we're going to solve it for the x and prove that everything matched. Okay? We're going to go prove that everything matched. So we're going to take that equation where we set them equal, made them balance, and we're going to solve for x. We're going to do our big ones and our big zeros. Like we've done before in the past, several of them. Okay, so we have to do our big zero. And our big zero starts by looking at our letters. Right, our big zero starts by looking at our letters. How are we going to big zero the x's? What are we going to do? Whenever we're looking at the letters, who moves? A big letter or a small letter? Small letter. So how are we going to zero out the smaller x? What are we going to do to zero out that smaller x? Subtract 1x from both sides, yes. So on the left, we're going to say minus 1x. We put the 1 back when we're solving so that we don't forget that we're not supposed to take the x off. We're just supposed to subtract 1 from the 3. We don't need it over on this side, though, minus an x, because we do want the x to be equal. Okay? So we zeroed our x, big zero. How many x's do we have left then? What's the left-hand side going to say? What's the left-hand side going to say? Solve the math. 2x plus 5 is going to equal what was left behind on the other side. What was left behind on the other side? Nice. Okay. So, have we handled all our big zeros? Have we handled all the addition and subtraction yet? No. What needs to go now? We need to move a letter away from a number. So this positive 5 needs to go. What are we going to do to zero out that positive 5 to both sides of the equation? Subtract 5 on both sides. So minus 5 from the 5, minus 5 from the 19. Right? That makes the 5 turn into 0, so we don't care anymore. What's left on the left-hand side? What's left on the left-hand side? $2x. And that 2x has to equal what? 14. So have we handled all our big zeros? Yes, so now we got to handle our big 1, right? We need that x completely and totally alone. Is it yet? No. So what are we going to need to do to get our x completely alone? The 2 needs to go, right? Divide both sides by 2. So 2x divided by 2 has to equal the 14 divided by the 2, right? It should be super familiar. Okay. So what do we get? Now, what did the x stand for? Okay, so to do fractions, we're in equation, and you hit the slash, it's with the question mark. You don't have to make it anything big deal. That's why we use our equation editor in CAMI. Stands for years. So this should say x equals 7 years, right? Not just 7. Because we're now talking about a regular situation. Do you get it? No, okay. That's why we're using this tool over here, that's the division tool. That's why we use CAMI. Okay, now, according to your solution, how many years will it take for the bunny and the cat to weigh the same number of pounds? Okay, so we're answering their question. It will take 7 years for the bunny and the cat to weigh the same number of pounds. All I did was use the words from the question. I didn't make anything special. Okay. Does this answer match with your answer in the graph on page 5-41? Was it 7 years on the graph? Yes or no? Yes. This answer did match the one from the graph. Okay. So far, so good? Any questions? Okay. So now they want to know how much will the bunny weigh. So this is the years that makes this balance, right? So we're going to go take their equations back from here that we had, our equations. And we're going to put the x in and confirm that the pounds match. Okay, now you do not, oops, I picked the wrong setting, 1 second. Undo. Equation. Now, you do not have to put this x into both equations. You just have to put it into one of them. So you can put it into either the bunny or the cat, okay? But whatever one you use to find the y value, the other one gets used to do the check. So which one do we want to use for our pounds and which one do we want to use for the check? Do we want to use the bunny's equation for the pounds and the cat's equation for the check, or the other way around? You choose. One of them is going to be find the pounds, and one of them is going to be check your solution for x and y. So who do we want to use to find the pounds? Bunny or cat? Which equation do we want to use? Okay, we're going to use cat for the pounds. So I'm going to go and I'm going to say that this is pounds, which means the other one is going to be my check. I'm going to put my x and my y I figured out into the bunny equation to make sure it works for both of them. Okay, so we're going to solve this pounds. We are replacing the x with the 7 we just found. And we're solving, replacing the x with the 7 we just found. So 7 plus 19, what does that equal? What's 7 plus 19 equal? 26 pounds. Okay. Remember, we need to put our units of measure. And this is where we put the L to S one. Okay. So we have now found the solution to the system. And the solution to the system algebraically ended up being a 7 for the x and a 26 for the y, correct? And I'm going to make this guy green because he's the solution for the system. One of the exceptions of not blue or red. Has to be blue. Okay. So now we're going to check that this 726 works for the bunny also. So we're going to put the 26 for the y has to equal 3 times the 7 plus the 5 more. Okay, so we have to check that that 726 worked out for both. Do we understand? What is 7 times 3? What's 7 times 3? Okay, plus the 5. Oops. Plus the 5. Okay, 21 plus 5. (26) equals 26. What do we get to put next to this? Because we're happy. We get to put a check mark. That one worked pretty good. Some days yes, some days no, right? Okay, so when you solve algebraically, you have to solve in 2 parts. Okay, the first part solves for one of the variables. The second part solves for the second variable and checks to make it sure that both work for the equation. Okay, so we're going to go try it again. We're going to start from the beginning. Okay, we're going to make the rule. We're going to solve the rule. Okay, that's what we're doing. We're not worrying about without graphing. Okay, without graphing. All right, so step 1, we have to make the rule. What situation do we have? What's going on? Okay, let's see. It says Post Falls High in Idaho has 1,160 students and is growing by 22 per year. There's the information for the first one. Gave us a start, gave us a growth. What letter in our equation stands for start? B. What letter in our equation stands for growth? No. What letter in our format stands for growth? Because what's our format again? What's the equation supposed to look like format-wise? What's our format supposed to look like? Y equals mx plus b. Yes, so growth is our m. Yes. X and y are our different entries on the table. Okay, so our goal is y equals mx plus b. Oops. That's what we want it to look like. So we're going to get some information post falls, right? Text box, sorry. Post falls. We're looking at the M, we're looking at the B, right? One of these should be the M. For both of them. We're going to make a little table of what the information is out of the story. Because oftentimes what happens is you get so wrapped up in the story, you lose track of the details. Okay, the other one is Richmond, right? So one is going to be red and one is going to be blue. According to the information that we just read, post falls, the M is going to be what? What's it growing by? What am I going to put here for its M? Because remember, M is growing. So what are we going to put for growing for post falls? From up in the story. What are we going to put for post falls? Up in the story, what did it say? What was it growing by? Come on. According to that story, what was post falls growing by? 22. Okay. And what was their beginning value of student? It's beginning. So 1160. Okay. Now we got to do the same thing for Richmond. According to Richmond, what's going on with Richmond? According to the story. Read again. What's going on with Richmond? Did it use the word growing for Richmond? Ah, it said shrinking for Richmond. So that's negative 15. Watch out for your words that mean positives and negative numbers. Increasing, positive, decreasing, negative, growing, shrinking, okay? Watch out. They matter. What did they have as a start, a beginning? $1900. Okay, so now we're going to use this information to make each one's y equals mx plus b. So this is my equation. Okay. Starting with post falls, y equals, my m was 22, times the number of years, plus it started with 1160. Because it tells you y stands for students, x stands for number of years. Okay, so what's Richmond's going to be then? What's Richmond's going to be then? Y equals what? What's its growth? Put it in y equals mx plus b format. What's it going to be? Come on, create its y equals mx plus b from its information. Yes, negative 15x plus 1900. Nice. Okay. So we made the equations. That's what it wanted. What was the rule for each situation? That's what we do for creating the rule. Graphing the rules for part A can be challenging because it has such large numbers, right? And it could take a long time to make a table. And we don't want to do that. So this is remember what I told you, that there are some situations when graphing isn't a very good thing, or making a table isn't a very good thing, because it's going to take a long time to bring 1900 down and 1160 up to meet each other. That'd make a really big table and a really big graph. So this is when we do the algebraic. Okay, so we need to set them equal. So what's it going to say? Set them equal. How are we going to set them equal? What would it look like? What's it going to look like? Set them equal, just like we did up above. Yes. So 22x plus 1160 has to equal negative 15x plus 1900. Okay? And we're going to solve this using our big zeros and our big ones. And we're going to solve this. Once we get the x, we're going to put it back in. For the y, we're going to put it back into check, just like we did. Okay? So get our balance beam in here. What do we always work with first? What do we always work with first? Smallest letter to biggest letter. So which letter is going to move and how are we going to move it? Smallest letter to biggest letter. Which letter is going to move and how are we going to move it? Which one's the smallest? Yeah, we're going to have to add that 15x to both sides because negative is smaller than positive. Okay, nice, nice, nice. Okay, so add 15x to the left. Whatever we do on the left, we have to duplicate on the right side. That will big zero out that negative 15x. How many x's do we have now? Do the math. What's the left side say? Exactly. 37x plus 1160 is going to have to stay equal to 1900, right? Because that's what's left on the other side. Okay. Are we done with big zeros? No, because I see that there's still a number on the side with the x. So we have to move it. What are we going to do to get that one moved? How are we going to zero it out? How are we going to zero it out? Yep. Subtract 1160 from both sides. Okay. So boom, minus 1160. Line him up with this guy so he zeroes them out. Copy to the other side of the line. Right? Line it up. All right, so that made that zero out. It's all gone, all left. What's left for the left side? What's left for the left side? Okay, 37x is all that's left. And that has to equal, do the math for the right side. Yes, you are allowed to use calculators if you choose. 740. All right. So we've handled all the big zeros, yes? We just now have to handle that big one, right? We have to get this 37 away from the x. How are we going to undo it? What are we going to do to make that 37 go away? Because right now it says 37 times the number of years, right? And we don't want times anymore. We want to undo and multiply. So what are we going to say? How are we going to undo multiply? Okay, yep, divide. Okay, so watch. We're on our equation editor, right? We type in our 37x. We hit the slash that's with the question mark. It creates the fraction. And then we arrow off it so we can get to the equal sign. And that's the 740 slash 37 as well. Whatever we do on the left, we have to do on the right. Okay. 37 divided by 37, the number 1. We do not care about 1 times things. That's why it goes away. We have x equals what? Do the math on the calculator. How many years will it take for Richmond to come down and Post Falls to go up so they can meet at the same population? 20 years. Okay. Okay. Solve your equation to find when the populations are going to be the same. So the populations will be the same in 20 years at Post Falls High School and Richmond High School. Okay. Yeah, abbreviate high school. Okay, are we okay with that? Now do you get how to do fractions now? Okay, so now we have to find out what the population will be. So we're taking one of the equations for finding the population and one of the equations for the check. Does it matter which one is which? No. So we're going to bring both of the equations down below and we're going to pick which one do we want to be the population one and which one do we want to be the check. Okay. Someone tell me which one should be the population one and which one should be the check. Because we're going to put it above them so we know which one's which. Which one are we going to use for population? Which one are we going to use for check? Which one are we going to use for population? Which one are we going to use for check? We're going to use them both. It doesn't matter which one. Okay. So since no one's choosing, I will. This will be population. This one's going to be our check. Okay. So we're going to take our x, we just figured 20, and we're going to put it in for our population. So y equals 22 times 20 plus the 1160. I'm figuring how many students are there. Okay, use your calculator. 22 times 20, what do we get? What would you get? 22 times 20. Someone give it to me. $440 plus the 1160. So we need to find out a final. What do we get? 1,600. Okay. 1,600 what? You got to tell what their units of measurements are. 1,600 what? Cars at the high school? Chicken? Students. Okay, so we need to answer their question. There will be 1,600 students at both schools in 20 years. Okay, now we got to go check that our situation works for both. Remember, when we're solving this, we got the x from up above and we got our y just now. So we have the coordinate of solution, right, or green, of 20, 1,600. We need to check that that 20, 1,600 works for this one, works for the other equation. So I'm getting my red. I'm saying my y was 1,600. Negative 15 times 20 plus the 1,900. So I replace the x and the y in Richmond's equation to make sure the situation 20 and 1,600 works for them as well. You have to check with the other equation. What is 20 times negative 15? Negative 300, subtracting 300. Oops, I forgot the minus sign, sorry. Okay, so do the math on the right-hand side. What does it equal? So what do we get to put right here? We get to check, right? It worked. Questions? Because we still have this one over here. So we set them equal to solve for the x, okay? Once we get the x, we use that x in one of them to get the y, and then we checked the x-y pair in the other one. Okay, let me see what this says. Find the solution to the problem below by graphing and using the equation. The solution using both methods should match. So be sure to review your work carefully. Okay, guess what we're not going to do? We're going to practice our solving our equations. So step one, we need to get our equation made. To get the equation made, I want you to use this little format that we made right here. Okay, this format here. So I'm going to go select, and I'm going to copy my format I did right here with the N and the B and equation. And I'm going to put it over here and change it slightly for the new situation. Okay. So I'm going to select. And I got to be on a text. And it did it, and I put it in a weird spot. Sometimes it's easier to undo and try again. Okay. Select. I want this. I'm going to copy, and I'm going to paste it. And then I move it where I want it to be. And then I'm going to change it. Okay. See, I'm still learning Canvas here. Okay, so we got to look at what our situations are. What are the situations? What information they tell us? So imagine your school planted 2 trees when it first opened. One of ficus, the other an oak. So we have our, one of these is F for ficus, right? And one of these is O for oak. Okay, then it tells us the ficus was 6 feet tall when it was planted. So where is that going to go? Is that an M or is that a B? That's a B. So we're changing our B number to be 6 feet tall. So we only need the 6. Nope, our M number. Sorry, or start with 6. But our B number, how much did it grow each year? Our start, 6 feet tall, is the B. I'm losing it, man. Sorry, you guys. This is the 6 feet tall. I was right. I second guessed myself. Okay, what's our growth? 1.5. So what's our equation going to look like? 1.5x plus the 6, right? Okay, oak. How much growth? Two. Okay. Read carefully. Where did it begin? How tall was it when it began? Tall means above ground, right? What did it say about the oak? It was grown from an acorn on the ground. So how tall is it when it starts? How far above the ground is it? If it's starting on the ground, is it above the ground? No. So he began at 0, tall. And yes, we are going to only have a 2x, because does plus 0 make a difference? Does adding 0 make a difference? No. So do we understand why the second equation has no plus or minus? Okay. So now we're going to set these equal to each other. 1.5x plus 6 equaling 2x. And we're going to solve for how many years it takes the trees to catch up. Okay. What are we going to do? Put our balancing in. What are we going to do? Who has to move? Okay, we have to subtract 1.5x from both sides, exactly. So 1.5x goes over to 2x. So it's in our best interest to write this as 2.0x. So they both have a decimal place, right? So I'm going to subtract the 1.5x from the left. And whatever I do on the left side, I have to do on the right hand side. And I added the 0.0 in because with decimals and subtraction, you got to line up the decimal. That's the rule. All right. So what's left on the left-hand side? What's left on the left-hand side? 6. And that 6 has to equal what? If I start at 2 and I subtract 1.5, what's going to be left? 0.5x. Okay. So now I'm going to big one. This 0.5. Okay. I'm going to big one that 0.5. So my 6 has to divide by 0.5, right? And my 0.5x has to divide by 0.5 so that I could big one that away. Now, use your calculator. What side should the letter be on when we're done with this? Which side should the letter be done on? Which side, when we're done, does the letter land on? When we're solving equations, where should the letter be? Left or right? Left. So this is going to say x equals, use your calculator. What? X equals what? Use your calculator. What's 6 divided by 0.5? Use the calculator. 12 what? What did the x stand for? No, look again. When will the trees be the same size? It's the when. X is always the when. So 12 what? What? When were years. Okay. So we're going to have to take one of the equations for finding the y and one of the equations for the check. Who's going to be the find the y? Who's going to be the check? Okay. Which one are we going to use to find the height? And which one are we going to use to check? Because remember, we have to use both. Ficus for height. Ficus for height. And oak for check. Okay. So ficus for height. Let me get this one piece on here. You guys are going to finish this before noon, but I want to get this piece written on here for you. Okay, so this is going to be height. This is going to be your check. Okay. You're going to finish that part, find the height using the one equation, do the check to make sure, tell me the coordinate, just like we did in the last problem. Sentence answer at the end, right? And you have until noon to get that done, okay? If you turn it in without those done, it's only at 50%. If you turn them in with the done, then you get 100% if you've done everything. Are we clear? Okay, have a good day.